What we have here is salt powder. It looks like this when we buy it from the chemical factories that make it. Purify them and eventually we melt it and it becomes a molten salt. And then when that molten salt freezes again, it looks like this. So this is a ingot of molten salt, roughly 1 kilogram. These pumps are made for pumping molten salt at up to 700 degrees Celsius. When we first wanted to build some of our first test systems, we actually called many pump companies and asked them if they had some pumps that we could buy and modify so we could use them for molten salt. But it was not possible for us to find any company that had molten salt pumps. So in order to just have the internal discussions, I was drawing this pump in a CAD system. And then I decided after I had drawn it that I wanted to print it in plastic, and it worked. It worked actually quite well, like after a week. And then I decided, okay, that was not difficult. So I decided to 3D print it in metal. Unfortunately, that didn't work. But then, we spent some money and we decided, okay, let's build out of steel parts. The way this pump works is that down here we have an electrical motor. So basically a three-phase electrical motor, just like it was invented more than 100 years ago. And up here at the top, we have the impeller and volute, which is what pushes the salt around and basically the pumping function. So this particular coupon has never been exposed to salt. So this is a brand new one. And then this one has been exposed to our molten salt, Copenhagen Atomics molten salts, for 1,000 hours at 600 degrees. And you can see very little change. And then this third one here has been exposed to the same salt as this one, but without the Copenhagen Atomics purification. We do a lot of this testing to figure out how different materials respond, also at different temperatures. So there's a lot of testing has gone into this. One of the problems with this one is that it needs service every now and then. The goal of this one is to have a pump eventually that can run for 10 years in this very harsh environment with molten salts, very high temperatures up to 700 or 800 degrees, and with a high level of radiation without any service for 10 years. This is like super difficult. This one here has electromagnetic bearings, meaning that all the rotating parts inside are levitating on a magnetic field when it's rotating. And this means that no surfaces are grinding against each other. We haven't finished the R&D for this one. This is still being developed, but hopefully in a couple of years, this one will also be up and running in many copies.